Okay, so we are going to discuss about negative binomial distribution. Now, if you remember, earlier we learned about the geometric distribution. So what's the geometric distribution? Let me write here. So the random variable x for geometric distribution is a number of failure before first success. Okay, and we were assuming that we are using repeated independent Bernoulli trials with success probability P. So each trial has same success probability. So now we are going to define a new distribution. Let's with change to geometric distribution. So now what we are going to call, let's say y. We call this random variable as number of failure before rth success. So you can see here we have first success, this is rth success. So it's a generalization of geometric distribution. And we still have the same condition. These are repeated, independent, Bernoulli trials, okay, with success probability P. So let's go to the distribution and see how it's look like. So we define X as number of failures before first success. This was for geometric. And now under new one, new random variable, we use M as a number of failure before the R success, where R is positive integer. So right away, you can see that M is going to be what? M can take which value? M can be 0, it can be 1, can be 2, so forth. So this is a number of failure before the R success. So you may have a situation where all your previous trials are success. So 0 success, and then the rth one also success. For example, let's say you toss a coin and you are looking for head. Okay. So the experiment is toss a coin, and M is number of toss a coin repeatedly. Okay. Number of I mean the success is let me write success. That is appear head. Okay, we're getting head. So so when you do this, so let's say we want to find the third number of failure before third success. So let's define M as number of failure before third success. So there are scenarios like, for example, your first toss, okay, can be head, and the second toss also head, and the third toss also head. So now you have the third success. This is the third success, okay, because our success is head. Okay. So in this case, M takes 0. Okay. Or you may have a situation where first one is head, the second one also head, but the third one is tail, and the fourth one is head. So in this case, M become 1. Because number of failure before the third success is the third success, and this is a failure. Okay. So M equal 1. Or you may have a situation where first one is tail, and the next one is head, next one is head, next one is head. So this is the third success. But number of failure before third success is 1. You have 1 fail, this is a fail. Okay. Or you may have a situation where first one is head, next one is tail, next one also tail, next one is head, next one is tail, next one is head. So this is our third success. But you have failure 1, 2, 3. So in this case, M is 3. Okay. So forth. So M can be 0, 1, 2, 3. It is countable in finite possibilities. So support of this random variable is countable in finite. The probability distribution of this new random variable is given by this formula. So here you can see the formula. So this is what you would get, but then you can show that these two are actually coefficients are same. Expert value is R time Q over P. So remember Q is what? Q is 1 minus P. Okay. And variance is R time 1 minus P over P square. So that would be the variance. So now there is a different formulation of negative binomial distribution. Now, if you look at this one, and if you say, let's think about let's think about y plus r. I mean the m plus r. Okay. So you have m plus r. What is this? Okay. So this is number of failures before rth success. Okay. So this is number of success. Okay, I mean basically R success. So M plus R basically give you what? This is number of trials need to produce exactly R success. Okay. So if you use that definition, okay, so M plus R, so I can say this is my new random variable Y. So in that, if I write like that, then probability Y equal little y. So that's going to be what? Then this entire thing is going to be little y. Okay, so it's going to be y minus 1, r minus 1, p r. And then this one, you can see that r plus k should be y. Then k is y minus r. So this, the way, if you write like this, that's also another way to write the negative binomial distribution. Okay. So in this case, this trial number. So in this case, this is what? This is the random variable. Y is trial number for R success. In here, we define number of failure, but if you use this method, I mean this parameterization, that's in that parameterization, the random variable is real machine trial number. Okay, so you have to be careful which one you are using. In this case, actually, y can be what? Because when you set m can be 0 to infinity, count to infinite. So when m equals 0, y can be r. When m equal 1, y can be r plus 1. So in this setup, y can be r plus 1 all the way up to infinity. So it started from r, not 0. So you have to be careful if you use this parameterization of negative binomials. This is another parameterization of negative binomial. But if you use that one, then the meaning of random variable is different from the previous one. In this case, y represent trial number for R success. In the previous one, M represent number of failure before the R success. So just be careful which one you are using, because when you are reading textbook, you would see both, and then you have to be careful. Okay, so here you would see a question. The question says Hunter want to train his shooting skill. Suppose the probability of success is 0.5. 0.45. Okay, so success is 0.45. Try to calculate the probability that hunter can hit the target the second time. So second time is a second success. So R equal to, so the second success in his fourth attempt. So fourth attempt mean like how many failures before that? So that means there should be at least, there should be 2 failures, no? So this is same basically this random variable. Okay. Trial number for our success. So this one telling me the trial number for second success should be 4. So if I use that formula for y equal 4, this is trial number for second success. So I can use the second parameterization of negative binomial, and I would write probability y equal 4. Okay, so I can use that formula. So S 4 minus 1, 2 minus 1. Let's check the formula. And P to the R, which is 2, and then 1 minus 0.25, y minus R. So when you get that, you get the probability. Now, if you want to use the first parameterization using M, M is what? If I use M is basically number of failures. Before second success. Okay. So we need the second success to occur in the fourth trial, fourth attempt. So in this case, there should be at least 2 failures before that. So, I mean, exactly 2 failures. So M should be 2. For example, you can have first one hit, okay, and then failure, and the fourth one is hit. Or you can have first 2 failure, and the next 2 hit. Or you can have first one hit, next one failure. Yeah, I mean, the same situation. Or you can have, yeah, so I think these are the only possibilities. Or you can have something like this, failure, hit, failure, and then hit. Because the fourth one needs to be success. So anyway, when you use this one, then you go to the first approach. So in this case, my K is 2. This is my, what I use as K, M equal K, remember? So this is R is 2 plus 2 minus 1. And then this one is minus 1. Go to this distribution, and P to the R, which is, and 1 minus 0.5, and then the K. K is in this case 2. So you can see that it's essentially the same. Okay? So this is probability M equal to 2 failures before the second success. Okay, so here you can see another question. It says X is negative binomial with mean 27. So right away you can write the formula. So what's the formula? You can see that RQ over P. So that's going to be 27. And the variance is RQ over P square. Is going to be 270. So you can solve for P first. If I take this is 1, this is 2. Now I divide 1 by 2. I mean, let's divide 2 by 1. So R cube P over R cube over P square. That is 27 over 170. And that would be is 1 over 10. This is 0.1. Once you know P, then you know the Q. Q is 1 minus P, which is 0.9. From there, you can get the R. So R would be, if I use equation 2, this would be R time 0.9 over 0.1. So R would be 3. So once you know PQR, you can calculate the probability that 5 failure before third success. So probably 5 failure before third success. Okay, so my R is 3. And the 5 failure. So M equal 5. So you can use this first approach. So R plus K, so it is K plus 1, R minus 1. And then here you will see the PR, K. So P is 0.1. Q is 0.9. When you simplify that, you will get the solution. Okay, I will leave the other problems. Please ask this question in the discussion board. Please utilize that tool. You should ask questions and then others can answer. And that way we can have a very productive discussion in our class. Thank you.